Good afternoon and welcome to our webinar on diversity in artificial intelligence. Really delighted to have you all with us today, and I hope that you're going to find the next hour very interesting. It is a hugely topical issue, particularly with all the noise we've seen in the papers around the exam algorithm in the summer and other such algorithms which really called into question the question of bias. But it's been something that's been around for a while, and we could probably talk about it for days. But in the next hour, we're going to try and touch on three key areas of the issue. One of which is really thinking about the way that you choose to approach your use of historic data, because if we do accept that there's some bias in historic data, then are there better ways that we can approach the way that we use it in order to try and reduce that bias? The second area is, well, how much historic data do you really need to use, and can you get value out of and great results out of approaching things differently? And we'll talk to you a little bit about that. And then the final piece is technology and data doesn't happen without people, and people are a really important part of it. So how do we make sure that we firstly remove bias in the actual recruitment process, and secondly ensure that we get a really great diverse workforce? Because if they're the people training the algorithms, then you're already introducing bias very quickly if you don't have a diverse workforce. And sadly, in the data industry, we are far, far from achieving that diverse workforce that we look for. But I am delighted that we have got a whole host of women speaking to you today on this webinar, which is rare in our industry. So we're making the first steps. And encourage others on the call who are not yet in data to come join us in this wonderful world. So I'm going to just hand over to the wonderful speakers we have today to say a couple of minutes of introduction about themselves, and then we're going to get going with a presentation and a bit of a discussion. You've got a chat on the screen where you can put any questions, and we really do want this to be interactive. So please do add comments and questions, and I will make sure that they get asked to the various different speakers. So first over to Maria. Maria, would you like to introduce yourself?
Yes, thank you. Good afternoon, everyone. Welcome to this webinar, ladies and gentlemen. My name is Maria Fasli. I'm a computer scientist by background, and my area of expertise is artificial intelligence. In fact, it is traditional artificial intelligence, as it would be understood in the context of having intelligent systems that can reason and they can do things on our behalf. I work for the University of Essex, and I'm currently the Executive Dean of the Faculty of Science and Health. I've been working in this area for a very long time, so I have seen it moving from obscurity into now being an area that everyone is talking about, data science and AI. And we have a lot of promise going forward, but there are also some risks and some obstacles that we all need to be aware of. So I'm really delighted to join you today, and thank you to Profusion for the invitation to contribute.
Hi everyone, I'm Chiati. Firstly, thanks for Profusion and Natalie for having me here. I run a company called Applied. We're a part diagnostic, part predictive tool, and it's end-to-end hiring. And our singular mission is to take the best available behavioral science out there and data science out there to mitigate bias in hiring. And this topic is really close to our hearts because we often get asked about how do you actually use artificial intelligence in making selection decisions and evaluation of candidates if you know a lot of the data, which is historic, will be biased. So looking forward to speaking to all of you about some of the interesting topics today.
I'm Henrik Nordmark. I'm head of data science at Profusion. I'm also a visiting fellow at the University of Essex, where I do some guest lecturing in statistics and machine learning. Also, I guess my academic background is a bit mixed. I studied psychology and mathematics and philosophy, so all very pertinent subjects to the topics to discuss today, and I really look forward to the discussions.
My name is Karen. I am a second year studying data science and analytics. I have created a society called Equality and Diversity in STEM, and this is my first opportunity in regards to speaking more about diversity in AI. Thank you for the opportunity.
So they are our speakers. I think I also managed to not introduce myself. I'm Natalie. I'm the CEO at Profusion. I'm very, very passionate about how we can start to take some small steps to at least tackle this issue. I'm going to hand over to Maria now, who's got a short presentation to really just hopefully get you mulling over and chewing over some of these really challenging areas of this topic. And then, as I say, we'll open it up to Q&A from you and from the panel to help bring all the different perspectives in. So over to Maria.
Thank you, Natalie. So good afternoon again, everyone. The title of this talk, or the subtitle of this talk, is From Algorithms to Fair and Trusted AI Systems. And I want to start by saying that if you are looking for this presentation to be offering you solutions, this is not what I am aiming to do. This talk is more about prompting you to think about the various dimensions of fairness, bias, diversity, and other related themes that are really important when we talk about AI systems. I also need to apologize in advance in that some of the animations that I had included in my presentation have been flattened out. So you will have to bear with me, I'm afraid, as I will be walking you through the otherwise animated slides. So what I would like to ask you for a start is to consider yourself as an individual human being making decisions on as part of your daily life. And if you had not heard about my introduction and who I am as an academic, if you were to see my photo somewhere as part of a profile, imagine it being presented to you as someone who is a CEO of a company and you're looking to hire people and you see my photo, what would you think about me as being capable of doing? An administrator, perhaps, a bank employee, a shop assistant? Would you ever consider me to be capable of being a fighter pilot? And I want you to think about this for a few seconds and contrast that. This is where the animation would have come in. If you were to see another photo, the gentleman who is at the bottom of the slide, what would you think I would be capable of doing if I looked like this gentleman in this photo? Would you have me suitable as a company director, maybe a brain surgeon? The gentleman has a very, very nice gray hair, which shows maturity and wisdom, or perhaps he could be a professor of computer science. In fact, both of us are doing exactly the same job. We are colleagues in the same academic department. More or less, we have the same credentials. We have PhDs. We have studied. We are publishing. So we work in the same field. But our reality and the way we go about and we make decisions is being shaped by our experiences. And what tends to happen is when we store information and we try to access this information, we tend to generalize and we tend to oversimplify. So if you see a blonde lady with a fluffy kind of jacket, you would think, oh, she's a nice shop assistant. Whereas if you see another gentleman with gray hair, you would think that this is someone mature with experience, therefore someone who can be a professor of computer science. So we all need to be aware that we have our own biases that affect every decision that we take on during our daily lives and our daily interactions with people. We categorize people very quickly based on first impressions. So we really need to be conscious of these biases that we all carry. I would have animated here. I would have told you that perhaps you expect all minions to be yellow, but actually not all minions are yellow. Some of them are purple, it appears. So again, we tend to categorize, and if someone gives you a keyword, you make your own associations. So diversity can mean different things to different people. And I want to move now on and talk a little bit about AI and my perspective on artificial intelligence. And the kind of fundamental principle of AI as a discipline when it got started back in the 50s was to try and create intelligent behavior. So you have essentially an intelligent system in the middle. Very often we refer to this as an intelligent agent. And this agent is situated in an environment with other agents, and it has a purpose, it has goals. It interacts with the environment, it undertakes actions, and then there's a feedback loop from the environment, sensory data that come into this intelligent system or agent, and then some kind of decision making is taking place that you can see on the left side of the slide, which typically involves some kind of algorithm, the creation of a model and some data to create the model. And then the agent takes an action, again affects the environment, and here we go again. And to have truly intelligent systems, one of the basic characteristics of intelligence for humans is that of learning. And learning is the process of acquiring knowledge, skills, attitudes through experience, imitation, or teaching. But then the defining characteristic of learning is that you see changes in behavior. So we learn because we are trying to do things better, improve, and or apply knowledge that we have acquired in one domain in another domain. And hence we have the notion of machine learning. And I want to spend a minute on this because there's a lot of confusion out there. People tend to use the terms interchangeably. They talk about ML, they mean AI, or they refer to something as AI and this is ML, or actually none of the two. There's a lot of hype. So as researchers and as professionals working in this field, I see it as our role to actually try and dispel these myths and explain the differences. Because AI is not just machine learning. AI is a bigger area, and machine learning is one of the really, really key areas under AI. And there has been a lot of work, and we have made a lot of progress in the last few years because we have had access to a lot of data that before we have not been able to get our hands on. There are a lot of devices now that are generating data, and therefore techniques in machine learning, we have seen a lot of progress in this area. So, and you are familiar with applications of AI and machine learning, driverless cars, the recommendation systems that Amazon is using, and even systems that are being used in stock markets do involve some elements of machine learning and AI at times. And of course, you may be aware, if you are not, this is something that you really need to look at the Cambridge Analytica example and using data to make decisions and influence people. So what tends to happen is these systems use different types of techniques. And this is a very nice diagram that sort of summarizes for me the different types of techniques that you can have and their ability to give you answers based on different types of questions, but also their complexity. So if you look at the two axes, on the one hand, the you've got value, and on the other axis, you have the difficulty and the complexity of the technique that you are using. So when we talk about descriptive analytics, here you are using historical data, and the techniques that you apply enable you to understand what happened. So you look at historical data and you're trying to understand what has happened in the past. You move further up the scale of difficulty in techniques if you try to apply diagnostic analytics, because you're not just interested in seeing what patterns you had in the past, but you are interested here in understanding why you're seeing specific patterns. So it's the reason. So this gives you a lot more information, because then you can modify obviously your behavior. And you go a step up if you are trying to apply predictive analytics. And here you're using data, historical data, but you're interested not just in what has happened in the past, but you are using this in order to formulate a model that is going to tell you what's going to happen in the future. So you're trying to predict, and predictions are never 100% accurate. If anyone tells you that, then they are clearly they don't understand how predictive analytics works, because we cannot predict the future with 100% certainty. But this is where, for instance, a lot of the machine learning techniques lie as families of techniques. And then one further step up is prescriptive analytics. And here it's something far more difficult to try and achieve. So we're not just looking to predict the future, but we are actually looking to influence people's behavior. So we want to understand what kind of action here we would have to undertake in order to change the behavior of our customers if we wanted to achieve X, Y, and Z as outcomes. So the further up the chain you move, the more difficult the methods are, the more context dependent they are, and domain dependent. And of course, you are obtaining more value out of this, but they are not easy to apply, and you cannot move them from one domain into another. The problem also, as you go further up the chain, and depending on the kind of techniques and algorithms that you're using, is they can be at times quite effective. So you can get a good answer coming out, but very often, especially with techniques like neural networks, deep learning, deep neural networks, the problem is that you cannot really tell why you're getting the output or the answer that you're getting. They are very difficult to explain. So there is a problem around explainability and interpretability of the kind of answers that we are getting out of machine learning systems. And you will, of course, have heard of GDPR. A requirement of GDPR is if you're applying AI or machine learning, you need to be able to explain how is it that you have arrived at such a decision. But there have been a lot of studies that have shown actually this is not easy, and a whole new research area has actually got started on this, because it's really, really important. And we need to, when we talk about diversity and the use of AI systems, we need to bear in mind that we are talking about systems that are socio-technical. So in a sense, they are designed by people, they are implemented, deployed, and they are used by people, and they affect people. They are placed within organizations, and they are used and deployed within a social, political, legal, cultural, and economic, and very often even country-specific context. So these are systems that really affect our lives. And the data that are used in these AI systems pertain to individuals and groups, and the output that they may give you may actually be used for actions and decisions which can have very significant consequences on either individuals or groups. And that includes both vulnerable people as well as vulnerable groups. So you can have impact on minorities because of the way that you are using the decision out of an AI system to take action or to enact policy or to inform policy. So we need to be aware that as a technology, AI and machine learning, they're powerful. They are they can deliver a lot of good, but they also have a lot of pitfalls that we need to be mindful of. And diversity and fairness and the whole space that we are talking about is actually quite a multifaceted problem. It has a lot of dimensions, And as Natalie said in the beginning of this webinar, we can spend a lot of time, and certainly I have not been given the whole of the time myself, so I'm going to try and hurry up. So we talk about diversity under different guises, from employing people and making sure that our data sets are diverse, they're not biased. We talk about fairness, which are really abstract concepts, and we cannot necessarily provide very formal definitions. Then there are things like accountability, transparency. AI systems have the potential to harm both individuals as groups. So you can look at them from the point of view of human rights, and it's a complete minefield. And you start looking at them from that point of view, and you look at driverless cars, and you look at autonomous aerial vehicles. There's so much that you can say. We're talking about equality of opportunity. We're talking about bias, which can take so many forms. But we also talk about trust. And this is a conversation that also has to involve ethics. And ethics on their own tell us what is right and wrong. It's shared principles, values, societal rules, but it's not law. So we need to look at the legal frameworks as well. So you can appreciate that the topic that we're trying to touch on today is really multifaceted and really complex. It's interesting. It's one that it will be affecting our lives for a very long time, I feel, but we really need to work together to make progress in this. And conscious of time, I'm going to go through the next couple of slides quite quickly. A lot can be said about biases, and I hope my initial slide showing you my photo against that of a colleague of mine would have convinced you that there are biases. There are different classifications, if you like, or categorizations of biases when we're talking about bias in machine learning systems in particular. I have used a very specific one here that looks at this from the point of view of having biases at the level of data generation at this stage, where you can have historical bias, where you can have representation bias depending on how you sample the population. You can have measurement bias before you even go to the next stage, which is that of model development, and then its usage and deployment and evaluation. So here you would be talking about an aggregation bias being introduced potentially based on how you are working with your model, and the evaluation bias if you're using benchmarks that are already biased, and even if your own data set is not biased, if the benchmark data sets that you're using to evaluate against are biased, then you will be introducing bias into the decision-making process further down the line potentially. And finally, we have deployment bias according to this classification, where you as a developer or data scientist, you may have developed the system for one specific reason to give you an answer on a topic X, and then the user or the decision maker that is making use of your model may be using this output to make a completely different decision. So you can introduce bias in all sorts of different stages in machine learning specifically. And the same is the case for other techniques. And when we talk about fairness, as I said, this is quite an abstract concept. How can you define fairness? What is fairness, and who is defining it, and for what purpose? If you look at economic systems, for instance, we can talk about social welfare as a measure of fairness. We can talk about Pareto optimality. There are all sorts of concepts. Or we can look at statistical notions if we look at the data sets that we are using and the models that we are training and we are producing. Or you can look at fairness from the legal point of view, legal frameworks, where we can talk about unfair practices, or machine learning systems and AI systems being used to propagate unfair practices, or we can talk about protective characteristics, even discrimination. So when we talk about fairness, we need to have a common understanding for the specific context that we are referring to. What is it that we are talking about? Because there's no universally accepted definition, and this is very much context dependent. And I want to bring up trust here because it's almost implicit that we trust systems, we trust their outputs. And I think in this debate and conversation that we will be having, it's important to remember that AI has potential to create systems that can learn and modify and adapt their behavior. And we're not just talking about systems that can provide you a recommendation about a book. We can have systems that can actually take action on behalf of the user. They can learn based on user interaction or interaction with other systems. And if they are autonomous or semi-autonomous, because this is another fundamental sort of characteristic of true AI systems, how are we going to trust systems, AI systems, that they're going to do the right thing if they're learning? And for me, this is really, really important, and perhaps has not been considered as much in this debate. And diversity, we can talk about diversity in different guises. We can talk about diversity, as we will do later on, with respect to hiring people. So at the time of hiring, you may be introducing bias, or you may be using AI to help you hire people, and the bias could be introduced in this way. But we think about diversity and we think about all of these concepts from our own perspective, which I have to say, it's a very Western kind of perspective. One of my roles is I work with international partners under the UNESCO chair that I have in analytics and data science, and I interact with partners that come from all over the world. And my notion of fairness and my norms may not be the norms of people in South Africa or in Malaysia or in China. So we need to introduce in our thinking a wider perspective. So when we talk about diversity, we don't just think of ourselves, because we may not know, we may not understand what diversity means, what's fair, and what bias is for every other culture in the world and every other country and area in the world. So we need to be conscious about this. And you may think, okay, so what is our role here? Well, if we are data scientists and AI scientists, we need to be aware of the kind of biases that we can encounter in the data, or even the kind of biases that we can introduce by training different models, and how we create our algorithms and how we apply them. If we are developers, we need to think about the systems that we are creating and their potential for harm. If we are decision makers, and this is at the deployment stage, we need to be part of the loop. Humans need to be in the loop until we are absolutely certain that we can trust AI systems, because we are the ones that can interpret. We've made a lot of progress in AI, but our systems, our current systems, do not have the ability to reason. This is still with us. If we are recruiters, well, are we diverse in the workforce that we have? If we want to make a fair world, a more equal world. And if we are users and we are using these systems, are we aware of the data that are being released, that we are releasing, and then how this data is being used? And if we're the public, then we need to educate ourselves, and we have an obligation here to ensure that we understand the complexities around putting in place AI systems that can either take decisions on behalf of humans or support decision making. Because there are risks, there are great opportunities, and AI can offer amazing things in the future, but we need to work together in a very interdisciplinary way to make progress in this area. And I want to thank you for your attention. And that concludes my presentation. Thank you very much for listening.
Maria. So already had a couple of great questions in the chat, and hopefully that has really made people think. And I think it can get a little overwhelming when you start to realize that we don't even have the universal definition of fairness. So if we don't know what we're mitigating for, how can we mitigate it? But some really helpful tips just in our day-to-day lives of what we can do in terms of educating ourselves, in terms of as users of system being more thoughtful about how we're releasing our data and are we comfortable doing that, because fundamentally if people vote with their feet then we will get a faster reaction. And also as data scientists and developers, as we're creating things, to really make sure that we are challenging ourselves, that are we creating unintended consequences, and are we making sure we're reviewing the consequences of that. There are some really obvious examples where in marketing you would look at somebody's customer lifetime value and you'd say, great, we've identified the characteristics of someone who has a really high customer lifetime value. So now we're going to tell our performance marketing team to please go and get us as many more people that look like that as possible. And if you did that in recruitment and identified your employees with high lifetime value, then actually all you've done is go and replicate potentially bias that was already in the system. Because if you didn't have the right hiring practices 10 years ago when those people came through the system, then you may end up sort of totally compromising your diversity goals, totally compromising any goals around diversity and education pathways. And so we do really need to think about these things. We've got a few questions already, so I am going to ask Henrik to say a word on how would a business identify that it has bias in its data? How would they start to spot that?
I think first things to think about is really how was the data originally collected? And also, what is the population that you're trying to study? So to take a very simple example, imagine you're a perfume company or a soup company, and you're trying to decide how to launch your next perfume, right? Now, if you say, okay, I'm going to just like interview all the students at the University of Essex about their perfume preferences or their soup preferences, you might get a very interesting data set. But if your intention is to launch that across the entire UK, then that might be a particularly biased sample of people. It might bias towards just age, Essex students being generally younger than the population at large. It's also biased by nationalities. Essex is a particularly diverse and international student body. So perhaps not the best choice there. Now that seems like a very kind of obvious and trivial example, but there are many subtle ways in which companies do this all the time just because there's a convenient sample. This is the data I have easily accessible to me, so I'm going to base my decisions on that. And that's sort of the easiest way that bias gets introduced in businesses.
And then a few questions on recruitment. So I'm going to ask Kia to talk about that. And how do you identify bias in the process? And I know you used a lot of behavioral insights work to identify all the different biases, from us getting tired and lazy, and what time of day we more generously mark when we're marking answers. So perhaps you can tell us a little bit about that and what the role you think the role of a recruiter can be in terms of avoiding bias.
Sure. So I think starting with the simplest principles, there is explicit bias and there's implicit bias, right? And there's a lot of academic research which says in a couple of years' time from now, we will achieve neutrality in explicit bias. Explicit bias is essentially, I think you belong to a different culture, race, etc., and I think I'm biased towards you, but over a few years, I think across society, we will see neutrality on explicit bias. Implicit bias is what lives in our gut. Implicit bias is what we've absorbed from society and has a repercussion for every decision we make. It's the phenomenon that is present when you type beautiful babies on Google, and all you'll see is pictures of white babies. That is implicit bias. It's not that a coder has gone into Google and tagged the word beautiful with pictures of white babies. It's what emerges from the patterns and choices that people make. And for us to say we can get rid of implicit bias is almost impossible. With the billions being thrown in the US on unconscious bias training, there is no evidence that works. What works is structural interventions that guardrail humans when they take quick decisions. So when you put that in the context of recruitment, on average, you'll spend 6 to 10 seconds as a recruiter or a hiring manager on a CV. In that 6 to 10 seconds, you have millions of neurons firing in your brain. You will resort to mental shortcuts, which in other decision-making contexts are great, right? If there's a car hurtling down towards me on a road, I am going to move out of its way. That is a mental shortcut. That is an unconscious bias, and that's great in that instance. If I use the same mental shortcut or similar mental shortcuts when I'm looking through a CV, what will I do? I will look at how old they are, whether they've worked at Google before, if they're a coder, whether they've gone to a Russell Group university, whether they look like me, whether I can hang out at the pub with them. And all of these things are not predictive of talent. So I think there is a conversation around, do we even use historical data when it comes to recruitment? Because a lot of the historical data is perpetuated by tools such as CVs and resumes and going on LinkedIn to look up what the person has done. And it indexes heavily on the historic ability, not the future potential. And we at Applied are saying, why don't you look at what's more predictive? Everything that sits on a CV in bold is not predictive of talent. So the first advice to recruiters is stop looking at things that are not predictive. And if you don't use a CV, what do you replace it with? And there's litany of literature in academia that tells you what is predictive. What is predictive of talent is things such as work sample tests or cognitive ability tests. It's not whether you worked 5 years at Google as a developer. And so at the very beginning, we probably ask users to start, or hiring managers and recruiters to start looking at what their process looks like. Do they even have data in the past to see what's working or not working? I really like your example, Natalie, of the LTV and performance managers. It's exactly what we talk about. If you don't know what's working in the historic HR systems, there's no way you can identify and diagnose what the problems are and move forward. So even in terms of avoiding bias, it's very difficult for me to say you can avoid the implicit bias that sits in your gut. I'll give you an example. There's a specific paper that talks about how recruiters look at women and men, specifically when hiring for tech roles. And we know women are not very great at self-promotion. That's proven, right? And men are. So a lot of the bits that are on resume is dependent on self-promoting. So with the research, we have seen that on average, women will self-promote 10% or 20% less than men. So that already gives a lever for recruiters to look at the CVs that have been sent by men, because they will be more self-promotional in nature, and those keywords will match, whether it's a human doing it or an AI doing it. You'll still resort to some sort of modeling using keywords. And the second is, even if the women were to self-report at the same level as men, recruiters have a tendency, specifically in tech, to choose the male applicants over women. And this is proven in academia and research across thousands of applications. So it's these kinds of bias. It's very interesting to talk about how do we avoid bias. We can train ourselves that such a thing exists, but in reality, it's very difficult to say, I've done this exercise and I've done this training and now suddenly overnight I'm de-biased. That doesn't happen. As humans, for however many years we've lived on the planet, we've absorbed it. And the only way for us to mitigate those biases is have structures and interventions around us that guardrail us and prevent us from making mistakes in those most important decisions. I don't know if it answers the questions. I sort of went on a whirlwind tour of every little piece in recruitment that affects
Great,
biases.
thank you, very helpful. And there's another question, which is there some form of survey or test to check if the hiring person could be biased or not. And I think what Kiati is saying is any hiring person is biased. So we all are. But what processes can you put in place? So those cognitive tests, which will withdraw your ability to be biased or limit your ability to be biased if you don't, if you don't see names on CVs, if you instead look at future potential. And so I think that's one of the questions. The other question on recruitment, whilst we've got Kiati on camera, was do you consider ATS tracking systems in recruitment as part of AI?
Well, potentially depending on the outcomes and the problems they're trying to solve. So ATS, essentially applicant tracking systems, they have several components to their platform. So you could look at the sourcing component, where quite often they'd use an algorithm or some sort of AI to match a few candidates to the job description. And there are algorithms that are going in place there. And that could be an algorithmic making or an AI component there. There are other bits of AI components. For example, engagement with candidates often happens over chatbots. A lot of that is driven by algorithms and AIs. So that's another component. And then, of course, there's evaluation and sifting. So a lot of people, as is the case that you may have heard in the Amazon scenario, where they built a black box AI, and that was all based on what good looks like within Amazon. And the black box AI started discriminating against women. So only men of a certain age and ethnicity would get hired, and women wouldn't get called back for interviews. And that's, so there's multiple scope of AI within the applicant tracking system. As a platform, it is a tool and a technology. Where they use parts of AI is unknown to us. I think it was part of what Maria touched in. It's about explainability, which bits are black box, which bits are using AI, which bits are using algorithms, because some of the algorithms could just be simple if-then statements and simple rules, which may not be part of AI and be a very tiny part of machine learning. So it's important for us to understand where it's being used, which unfortunately quite often is the case. It's not explained to the user outside the platform.
Isn't just an issue in terms of our approach to recruitment, but also in the talent that we see wanting to come into the data and tech industry, which doesn't help when you're then trying to use those in other ways. Karen, it would be great to hear from you as a young woman who is embarking on your journey, just a little bit of your experience in trying to get into STEM subjects and encourage others to do the same and see this as a really viable career path.
Thank you, Natalie. In regards to my first experiences in this field in general, it has been very obvious that this is primarily a male-dominated industry. However, there are more students getting interested in this field, particularly women, but we are also aiming to have other genders. It shouldn't actually be gender typical of, okay, if we're doing anything in relation to nursing, that we have only women, we then, or for cooking, to only have men. We need a diverse background. We need more people in regards to both AI whilst technology is advancing, and the only way we can do this is to show and not teach, but to just give the society the different roles that we can go and offer, to show people that it isn't actually just for one gender or one race to do this whole topic of AI. The more diverse and more people we have from different cultures, we can then be able to have new ideas, new creative concepts to actually open up the field to having different concepts that we didn't actually think of, because we're all inside a little bubble in our own community, and we're taught one particular way because of our education system. But if we are able to then have other cultures come and join us, we are able to find out different things that we didn't realize, because we can all try and think outside the box, but it doesn't mean we'll be able to see it from a different view that others have been able to see. I hope that kind of helps with answering the question. You really do need to actually just show it out there, promote it, but don't promote it in the sense of marketing saying it's only for women. We need to actually be able to spread it out and say to everyone, hey, this is what we do inside technology in terms of AI. How can we go and actually address those issues about fairness and ensure that people would be interested in helping to ratify this issue?
So that leads us on, thank you, Karen, very nicely to a question which I am going to address first to Henrik, and then I'm going to ask Chiati to also give us an opinion on, which is, given that we have identified that there is bias, how do you feel about should or could we proactively create advantages for the victims, if you like, of bias through the automated systems we can create? So can we use the power of AI and automated systems to actually proactively address the bias and potentially up to positive discrimination?
Yeah, that's definitely within the realm of possibility. And in fact, we don't need to necessarily look that far in time or even in technology about how things can be corrected by kind of explicit design. I mean, perhaps the most salient example is things like affirmative action in the US, where there's like a conscious choice to try to rectify some of the biases and discrimination about the past. Of course, it has become extremely controversial in some ways, because then some more conservative leaning people felt it's like, oh well, is that maybe introducing another kind of bias? But we definitely, within the algorithms, we can do stuff to proactively rectify real or perceived biases. And I think a great example, a bit closer to home here in the UK, is what happened with all these students who were applying for university admission, and they felt unfairly treated because students that came from schools in poor, more disadvantaged areas ended up getting lower scores, not through any fault of their own, about anything to do with their own ability, talent that they had demonstrated over the course of the academic year, but just because historically that particular school may have underperformed. So then the algorithm kind of forced a certain number of A's and U's for that school, which is clearly unfair. But we need to remind ourselves that this is not the fault of the machine. This was, a human at the end who made a policy choice and a design choice as to how that algorithm should be constructed.
Chiati, do you have a view on, should we be looking at our recruitment systems and proactively changing them to address the victims of bias? And is addressing it enough, or do we need to proactively go the other way?
Yeah, sure, Natalie. It's really tricky, right? As a subject, I think just firstly, what is within the legal framework? As we know in the UK, positive discrimination is not allowed. And we've had a lot of requests from customers asking for that. And even though we can rectify within the algorithms, as Henrik stated, it's not something we would want to touch because it's illegal. Now, that is, of course, different as per jurisdictions. It might be all right in different countries and different cultures. But coming back to the UK, I think what we could do is specifically looking at our wheelhouse, which is hiring, looking at how we can use algorithms for positive action. And in the simplest way, if you think of positive action, that is, if you think, or if the hiring team thinks two people are of a similar merit and similar capabilities, then you would choose the candidate who is from an underrepresented background. And you could design algorithms that flag that ahead of the process being completed. But of course, there are, as with any algorithms, there will be positive and negative uses, and there will be unintended consequences as to how users would use it. And it relates back to Maria's point of deployment bias. How the user uses it is then also up for debate, because that might create issues, unintended issues that the designer of the algorithm didn't think about. There's another part to this, which is we're talking about, and this is again within the context of hiring, we're talking about addressing victims of bias, but that's in the context of hiring a lot to do with historic data. And at Applied, we believe that there is a way to do this without using historic data, which is why we don't use CVs, we don't use historic data to judge potential, and we don't use historic data to judge talent. And we've seen this over 200,000 applications across the globe, that we've been able to get more women into tech, we've been able to get more women into STEM, and we've been able to get more Black people, brown people, and all sorts of people from all walks of life into STEM. And the benchmarks are, well, if you look at what a traditional CV process would get in the jobs with comparing women in tech, in the UK, that's about 30% of women in tech jobs. With Applied, we've been able to increase that to 45 to 50%. So it's already 1.5 to 2 times more effective by not using historic data, because we're not compounding for those biases. And yes, it's not for everyone, but there is a way to do hiring without using historic data and all of the problems that come with historic data.
More question, which is the effort to be more diverse during the recruitment process, in your experience, bigger in London than in the rest of the UK? And does that make hiring outside London even more biased, or do you not see that? Do you feel that London firms are sort of leading the way on trying to tackle this issue, or do you think it's sort of varied across the UK?
I think it is varied, but the average awareness on the street is rising. If you see, I was doing this yesterday morning, and if you type unconscious bias on Google, the trend line is some 500x or something in the last 1 year. So people are more aware, and people are trying to understand the implications of unconscious bias within their recruitment and diversity. Yes, there is also a point of London being the hub. There is more public debate, there is more local debate, and therefore it's possible that a lot of the initiatives are coming from people in London. But as such, across our clients, we haven't necessarily seen a statistical difference outside of London and the UK.
Thank you. And we've talked a bit about not necessarily needing to use historic data. And Henrik or Maria, I wonder if you can talk a little bit more, not just in recruitment, but about how we don't use historic data, and a future where we perhaps don't need to do that in order to be predictive.
Thank you, Natalie. So there are different ways to go about it. The first thing to understand is, obviously, we can use human expertise to judge whether data that we have, data sets that we have are historical data sets that are really biased. And what we can do is essentially set them aside, and then we can use techniques and we can simulate, we can add data to historical data so that we can eliminate biases in this way. Or we can work, all of us, a lot more on techniques that don't make use of historical data in the same way that current machine learning algorithms are relying on.
Minutes ago, so I'm going to make sure that we wrap up on time. I hope everybody has enjoyed it. It's a big topic and we have really only scratched the surface today, but if you're interested in more information or a more technical webinar on the different techniques that people can start to use, or a more focused webinar on recruitment, obviously we're really happy to help with that. So please do share your feedback with us after the session. The recording will also be emailed out to you, so I know some people were asking about that, and really grateful for your input and for keeping the questions flowing. Very grateful to our fantastic presenter Maria and our wonderful panel. Karen, thank you for doing your first ever webinar. It's brilliant to have your voice being heard, and really look forward to what you're able to do for other young women and people from different ethnic backgrounds coming into STEM, and encourage them from your new group at the university. Thank you very much to everybody, and we hope to see you at our next webinar. Take care.